Welcome to another episode of I Am Nano.
Putting the I in I Am Nano, I am your host, Irfani.
And I am your other host, Monica.
And today we will be talking about progress in nanotech built armor that could replace Kevlar in military applications.
That's right. And now Kevlar is a synthetic fiber discovered in the 1960s, where the molecules are all parallel to one another, and it has a six-membered aromatic ring or a benzene ring, all combined with nitrogens and oxygens.
Right, so basically it has a lot of intermolecular hydrogen bonds between the nitrogens and oxygens, and then the aromatic ring stacking between the adjacent chains of the molecule to make it a super strong material. So strong that it's the most common material in bulletproof vest and body armor.
Yes, very popularly referenced as well in media and movies, especially. But as amazing as the material is, it still has its limits.
Right. So it can still be torn by shrapnel or pierced by super high powered bullets. So especially for military, you want to eliminate, any risk of it being broken.
Yes, exactly. And that's where this study using scientists and engineers from MIT, Stanford, Caltech, and ETH Zurich comes into play. And it's from Nature Materials in 2021, and it's called Supersonic Impact Resilience of Nano-Architected Carbon.
Wow, that sounds very fancy. Quite the title, eh?
Yeah.
So let's unpack that. What is a nano-architected material in the first place?
Great question. So, a nano-architected material consists of a patterned nanoscale structure that, depending on how it is arranged, can give materials unique properties, such as exceptional lightness and resilience. So, as such, nano-architected materials are seen as potentially lighter and tougher impact-resistant components. And in this paper, they use nano-architected carbon as the source material.
Mm-hmm. So the type of carbon used was called the pyrolytic carbon. It's a man-made substance produced through high heat to decompose it. And so that's the pyrolysis process. And this pyrolytic carbon is very similar to graphite, has graphene sheets in it with imperfections.
Exactly. And what the researchers here found was that the lattice structure of pyrolytic carbon, which is heavy on struts and open spaces, was stronger than a denser structure with less room to absorb or diffuse impact.
Right, so because of these nanostructured struts and divots, the surface can absorb a lot of shock or impact versus something that's just, fully dense and planar made of a single structure.
Right. And now we have the other term in the title of supersonic impact resistance.
Mm-hmm.
So that part is essentially, well, supersonic, that term meaning traveling faster than the speed of sound. So basically, the team exposed the nanocarbon material that they created to microparticles running at these supersonic speeds to see how the material would react when exposed to these high impact projectiles.
Mm-hmm. So in the research, in order to launch a nanoscale projectile at the carbon structure, they aimed the laser through a slide that is coated with gold, and then the laser pushed the particles at the target at very high speeds, which were from 40 to 1,100 meters per second, well within the supersonic range that's usually around 340 meters per second.
Yes. And so the low end of that is about 89 miles per hour or just under 145 kilometers per hour. So for some people, they can manage to, drive their car that fast. Mm-hmm. Or another example of that is that's approximately the speed of a fastball from a major league pitcher. Now, on the high end of those speeds, we're talking about almost 2,460 miles per hour, which is almost 4,000 kilometers per hour, or about 700 miles per hour faster than the average bullet.
Wow. That's super fast, 145 kilometers per hour. But how are they detecting that? Are there like mini microscopes similar to the ones we see in the road?
that police officers use to pull you over.
Yeah,
I don't
exactly.
know that. Well, yeah, actually, in a way, that's pretty much exactly right. The researchers were able to capture videos using high-speed cameras of the microparticles making an impact with the nano-architected material.
I see. Fancy. And also the quality of the scanning electron micrographs images, the SEM images, they're very, very interesting. You can see the types of dents and the impact that the particles left in the carbon structures. It's really, really cool.
Yes, it's very well done imaging. I agree. And another aspect is that the researchers made materials with two different densities.
Okay, so one is less dense material, thinner ones, and then a thicker version.
Exactly. And what they found was when they compared both materials, that the impact response was observed of the denser one to be more resilient. And microparticles tended to be embedded in the material rather than torn straight through it. And they do provide videos of these particles actually being launched at these square 3D nano architecture structures as well. And they're all freely available in the supplemental information. So anyone can go check it out.
Wow, that's really cool. So then when hit at high speeds by the projectiles, the material crumpled where directly hit, but the remaining structure actually stayed intact. And so by having this space to absorb and then dissipate all of this high energy hit from the specific squares design, the nanomaterial architecture remained intact. And then you can see that the projectile is embedded in the frame, but doesn't necessarily pierce through it, you know? And it's really amazing to think that by just changing the architecture of the material can significantly affect the material's properties.
Yeah, I agree. Very amazing. And this is an amazing layer of protection that is being boasted as approximately 70% better
Wow.
than Kevlar composites.
Wow.
And if they're used at the same weight as the Kevlar,
Mhm.
or the material can be as strong as Kevlar, but at a much lighter weight. So
Mhm.
this really offers a sort of revolutionary way for new armor. And because it's actually a lightweight material, it could be easier to maybe use and wear, especially for head and the torso to get protection.
Yeah, for sure. I mean, of course, this was tested with microparticles to simulate the bullet projectiles. So we need to test it also against materials that are commonly used in real life situations. But nevertheless, this is still amazing.
Yes, great point. Yeah.
Yeah. All right, everyone. That is all the Nano for today. Take care.
And stay curious.